Great to be here. My name is Bruce Momgen. It's my second talk of the conference. My eighth conference since COVID, so hey. Yeah, I got one coming up, Brazil next month, and then Israel, Germany, and New York.
New York.
Yeah, New York. So New York at the end of September, so something to look forward to.
What's in New York, Bruce?
What's in New York? The conference, what?
What conference?
All right, go on, all right. What are the dates, somebody? September?
September 21st, 22nd. It's I can double check, but it's PGConf NYC.
I think it's 22, 23, isn't it?
Oh, that's the actual Postgres conference.
22, 23.
22, 23, dedicated Postgres conference.
Yep, PGConf NYC.
And I'll be there, my wife will be there, and a lot of other Postgres people will be there. How many people are going to be there? Let's see. All right, cool, all right. So maybe we'll get a couple more. I don't know what the next West Coast event is. Mr. Wong, can you help us?
Postgres specific or?
Just East Coast. West Coast, I'm sorry.
Postgres conference next week in Portland.
There you go. Okay, good. So yeah, we're pretty busy now. We got a lot of stuff coming. I missed a whole bunch of European one-day conferences. Past couple months, everyone was waiting for COVID to end, and then we got everyone just stuck it in there, and I couldn't go to any of them, but we had very good participation, so that's great. So yeah, my name is Bruce Momgen. This is my website right here. The slides that you're looking at are on that website, so feel free to download those. I'd be curious if anybody could pull up that QR from the back. I don't think you can. I think it has to be a lot bigger to actually pull up that little square. Steven, you should be good. Anyway, I've been with Postgres since 1996, with EDB since 2006. My primary job is actually to work with the community, and I like doing that. And then I spend a little bit of time on EDB stuff like customers and strategy and all that fun stuff. But today we're here to talk about Postgres 15. This has been in development since July of last year. We closed development sometime in around April of this year. I wrote the release notes and put them online. I'll have a link to those release notes in a minute so you can see exactly what's going on. But we're looking at about 180 features. And I picked just the top, the top 7 that I think are the most important. And I'll give you some background of why I think they're important, some of the history of how we developed them. And then I'll obviously take your questions whenever. Just feel free to ask them. But there's a lot kind of packed in here. There isn't one. This is generally a problem with Postgres, or a blessing. We're not a single trick focused group. We have a distributed team all over the globe, and they're all focused on different things. So the things that people focus in Asia are different things in Europe and Latin America, and different countries have different focuses, different companies have different focuses. So there isn't like a one thing always usually that distinguishes a release. It's basically a set of either initial features or a set of enhancements to existing features. And because you're putting them out once a year, you get major momentum even in a couple of years. Somebody, in fact, I see the gentleman here asked a question about, well, I use foreign data wrappers in Postgres 9 something. Have they improved since in 14? And we're all like, we had the panel discussion, and we're all laugh like, oh, that's pretty funny, because it's like night and day. He was saying it was too slow in 9, 9.4, 9.6, whatever he was running. And we're like, wow, it's like night and day. Like what we have today for foreign data wrappers is vastly improved over what we had before. So instead of being a big bang every 3 to 5 years, it's this basically cadence that comes. Probably the big. Any questions first? Okay. Probably the big feature here, the most visible one is merge. I don't know how many of you have heard of merge. It's an SQL standard command. It's designed effectively to allow you to take data from one table and merge it. Hey, you see that word there? Merge it into another table, okay? So imagine you have a batch job and you want to take a new data and you want to merge it into the existing stock data that you have. Maybe it's a data warehouse. Use the merge command, and it basically kind of merges that data into the new into your existing data. This has been often requested. It's been in development. Gee, it must be, I want to say 7, 8 years. And there's a reason why it was 7 or 8 years, because as we started to look at it, and I think we started to look at it about 10 years ago, I'm thinking back to some PGCon talks that I heard in Ottawa. We started to look at the semantics of the merge command as defined by the SQL standard, which we would have to follow if we called it merge, right? If we call it something else, we don't have to follow that standard. But if we call it merge, we have to follow the SQL standard. And there were some odd behaviors in how the merge command operated that we didn't really like. We thought it was suboptimal. It wasn't as clean. There was these cases where the operation could actually abort with unpredictably. And we just kind of looked at it and we're like, we understand the SQL standard has that, but this is really not the feature we want to give to our user base. So we started to look at upsert, which I think MySQL had, and a couple other databases had this concept of doing an insert and then an update, which you can imagine is kind of like a merge, right? But the big difference between the two is that while the merge is effectively set-oriented, it thinks of a batch of rows coming in to an existing table, the insert on conflict is row-based. So you define for each row in my set, could be one row, could be a whole table, how am I going to merge that data in? And that's where we came up with the insert on conflict syntax. It's the insert, which we've always had, and then this on conflict clause, which I believe, again, we've had for 7 or 8 years. And the difference between the two is kind of interesting. The insert on conflict really doesn't have abort behaviors that I can think of. It doesn't sort of arbitrarily say, oh, I can't merge it and I've got to stop, which unfortunately the merge command has. And it's also fairly easy to define what happens when there's a conflict, right? It says on conflict and you can say ignore, you can say over update, or there's a whole kind of nice syntax there. But still, even though we had the insert on conflict, there was a demand for merge, again, for 2 reasons. The first reason being that merge was SQL standard and some people had been using it. But there are actually 3, there's another reason, and that is that the merge command is join oriented, okay? Which means that you're not, if you're loading a whole batch of data into an existing set, you're not doing it row by row in the same way internally that an insert on conflict does. And there's some behaviors that are a little different. So when you start to see what merge does, it is a join-oriented operation. You basically perform a join between the original data and the data when you merge, and then you kind of bring it in. Very different in behavior than the insert on conflict, which is basically just taking, okay, I got a pack of rows, let me just bring them in one by one, right? So it is a little different. The other issue also is that the insert on conflict would require some kind of unique index. So you need a unique index to perform insert on conflict, and most people didn't have trouble with that because, again, they were merging data, wasn't a problem, but it is a limitation, and there are some cases where you'd want to merge data in not necessarily because of a unique index. Again, when you're thinking of row-oriented, it makes perfect sense that you would require a unique index. But if you think of set-oriented, there could be cases where you'd want to join in data that may not have a conflict, and you still want to join it. So you basically join the data together, and then you define how it comes in. But again, one of the weird behaviors of merge is if there's concurrent activity on that table while you're merging, you can get a failure. And that's what I was talking about, the idea of unpredictable aborts or unpredictable failures of the query, which nobody likes. But again, because the way the merge is set oriented, you get that behavior. Let's look at some examples because I'm talking too much. So here we have a table called test. I've got 2 columns, X and Y. I get an A for creativity there. And then I insert the numbers 1, 3, and 5. So 3 odd numbers. okay? And then I'm going to show you the insert on conflict syntax, where effectively we're now inserting 1, 2, 3, 4, 5, 6. So as you can see, the 1, the 3, and the 5 are going to conflict, right? And the 2 and the 4 and the 6 are not going to conflict, right? It's pretty easy. And you see the unique index requirement right away. You get an error right here because there's no index to conflict on, right? So it just says there's no unique or exclusion constraint matching the on conflict specification. We can't do it, okay? So it's just going to fail. Then we create a unique index on the first column, x, okay? And then we do it again. And we say insert into test values 1, 2, 3, 4, 5, 6. And if there's a conflict, we want you to update the second column to true. We don't care about, we're not going to insert the actual, we're going to insert the value, but we're also going to, if we have a conflict, we're not going to make two versions of that row, because we can't, because we have a unique index. So our alternate behavior, this is not merge, this is what we've already had on conflict. We're going to basically just set the Y field to true. And you can see the results right down here. For 1, for 3, for 5, we have not added another 1 and 3 and 5 here for the insert. We've merely set the second column to true. The nulls, which you see here, are there because we effectively have not changed those. Remember, we didn't specify the Y column, so therefore you don't have a field there. You just have a null. Okay. Those of you who were in my null talk yesterday know exactly what I'm talking about, because when you don't specify a column in the field, then it just kind of it makes it null. Okay. Any questions? Okay. Great. Okay. Let's look at merge. So we just delete what's in the table again. We put 135 in again. Okay, and now we're going to use the merge command. You can see how it's quite a bit different. We start with the word merge, not with the word insert. So it's a new command completely. We name our table test. So I should probably use my little pointer here, right? And then we're going to do 1 through 2, 3, 4, 5, 6. But then I actually have to use a values clause here. And actually, we name the values clause M, and we name the clause X. So because remember, we have to do a join, right? This is not a row operation. This is a join operation. So again, we don't have to have the unique index because we're going to join the columns we want to join. It's kind of cool, right? So I'm actually creating a virtual table right here, and I'm calling it M for merge, and I'm calling the column X, right? Pretty easy. And then my next line is on, and then test x equals mx. This is my join right here. If you've ever seen the ANSI syntax, it's inner join on, whatever you put the clause, and that's exactly what we're doing here. And then you've got this curious kind of clauses down here. This is very simple. You can do a lot more to this than I'm showing you, but I just want to get the concept across here, right? So we say when there is not a match in the join between test and M, we are going to insert the value. Very similar to what we did with the insert. Remember, if there's no conflict, the insert happens. If there is a match, meaning there's a conflict, right, we're going to set the Y column to true. And look at this, we got the same output. Isn't that cool? Okay? But you can see how different this is, how it's basically kind of pulling this together in a join way, in a different sort of concept. So I'm excited about this. There has been some, Simon Riggs had a really good talk at Postgres Vision in June. You can watch the recording of that where he just talked about merge, and he goes into a lot of details. And there's where clauses you can put on the when, and very sophisticated stuff that you really could not do in insert at all. The insert on conflict doesn't have that smarts in it. So I'm kind of excited about it. It's going to take a while, I think, for people to really understand when to use each one. But again, internally what's happening is that the insert on conflict is really doing an insert And then if it conflicts, it's doing something else. This is not doing that. This is not starting out assuming an insert, right? It's basically doing a join and then processing the data. So this is a lot more, I think, applicable to something like a data warehouse case than an OLTP. Usually an OLTP, you're probably just going to stick with insert on conflict because you're probably just doing one row. You just want a very clean, API. But this can be very useful and in some ways more efficient because you're not doing all these individual inserts. You're basically creating a join result and then handling it that way. Any questions? Was I confusing? Has it worked? Okay, great, thanks. It took me a while to process, why do I want this thing? Why do people keep asking for it? It's kind of embarrassing, but I remember a similar case when we added the range types. I don't know, how many of you know about Postgres range types, right? And I remember talking to Jonathan Katz, who should have been speaking here. I'm replacing Jonathan, right? Or no, he was previous. Jim Olginski replaced Jonathan. I'm replacing Sarah? Mark. We don't know who I'm replacing. Anyway, yeah, I got you. Okay. So what's interesting is there's this merge command, there's range types, and you can put two fields, combine them together. And I'm like, well, why would you do that? There's you just make two columns. And he's like, no, because you can create sophisticated indexes between the two of them in ways that you can't for a normal single column. I'm like, oh, that's really cool. So again, this is the kind of case where when I started out, I'm like, oh, this is just another insert on conflict, just different syntax. I'm like, not really. It's really different. And it's going to take a while, I think, for people to understand when to use this and when to use the other. And our documentation is pretty good on that, but I'm always open to improving that and stuff. And I'm always looking for doc improvements. So it seems to be my thing for a while. Okay. Second, SQL Json functions. This is something, thankfully, we've been at this JSON thing for at least 10 years now. Started with standard JSON and then JSON-B and the gist indexes and the gin indexes and then the SQL standard syntax, which is what we're doing here. And then we just keep enhancing this thing to the point where the SQL standards committee liked what we did so much that they made an SQL standard for JSON. And this is us kind of adding that to some extent. So we've added a whole bunch of new SQL functions that make it cleaner to do JSON in SQL. I don't know how many of you have done JSON in SQL. I have some talks about it. But the API between SQL and JSON is not always super clean. In the early years, it was a lot of very sophisticated function syntax, and you'd have to put special stuff in quotes. It was just kind of awkward. It didn't read real cleanly. So one of the ideas here the SQL Standards Committee came up with is more of a clean design for doing JSON and making it look a little more like SQL, right? So we now have JSON scalars, the ability to create JSON scalars and objects and arrays, sort of using a standard syntax instead of using a function call that has a weird syntax to it. We have now a test of the type of a JSON value, the existence of certain paths in JSON values. We can apply JSON paths, and probably the last one is most interesting. You can take a JSON document and then make it a table with columns and rows, right? Which is kind of crazy, but you can understand why that would be really useful. If you're interested more in this, Oleg Bertunov had a good talk in June at the Russian conference, but I think he also did it. No, I think he did it at Vision as well. So if you want, look for Oleg Bertunov. The Russians have been pretty instrumental in a lot of this JSON work and the non-traditional data types in general, and they continue to provide great solutions in that area for us. Okay, any questions there? Okay. Logical replication. Again, I remember I said earlier that we don't really have one huge feature a lot of times. It's a lot of incremental improvements. And because they're coming out every year, it's not so bad because you only have to wait a year or two and you get a really, really cool feature. Logical replication, again, we've had 10 plus years. And we continue to refine it. Very similar to the way we continue to refine partitioning, and as I said, foreign data wrappers and JSON. There's a lot of this, get the initial feature in and then continue to enhance it as we go. Frankly, commercial companies, commercial databases have a tendency to plop a big feature and then stop. You see that a lot. Or they may plop a big feature and then maybe they'll improve it once and then it's just kind of stagnant. Because we're an open source project, there's a lot more dynamism. That's why PSQL is so cool, because every year it seems to get some new thing that it does. And logic replication is no exception. These are not, super amazing improvements, but again, they're part of that path that we continue to go on. And as we talked about yesterday in the discussion, ask anything we did the last session, this logic replication is part of a larger process of being able to handle upgrades more smoothly and being able to do distributed Postgres more smoothly. So it's kind of part of that entire ecosystem that we're building on. It's not clear sometimes where we're going, but as we build it out, new opportunities appear, and then every year we're kind of adding to that. So one of the problems that we used to have was that if you had to previously, every individual table had to be designated as part of a logical part, as published. So you'd have to publish this table and then this table and then this table, right? And as you imagine, if you're creating and removing tables all the time, it's kind of a pain, right? Because you're having to create the table and then set a publication and then kind of play around with subscribing to it and all that other stuff. So one of the cool things I think in this release is you can now publish an entire schema and then also say any future tables also will get published. So you just say, like any schema, you just give it the schema name and you say that subscript publication is that schema, and then anything gets created in the future, that's also part of that schema. And that obviously makes it easier for developers. Another one which I think is pretty cool is you can now control which rows get sent. Because previously, you'd have to publish a whole... You can see, if you squint, you can kind of see how these things would allow you to build out more sophisticated systems, right? Particularly the where clause, you could effectively almost think of it leading in the direction of bidirectional replication for a single table. You could have some rows, you could have some rows where clause published this way, and then the other with different where clause published the other way. Now, we're not saying we're going there, but it's something that now becomes possible because you're not necessarily publishing the whole table. Because now you can control which rows get sent. You can control which columns get sent too. So you could start to slice up a table this way and sort of send different things. Or maybe not send columns you want to be secure to the... That's a great use for it. Yes, sir?
Yeah, I wasn't quite sure. First line, publication of entire schemas, including future table edition. I'm not sure how that.
I'm sorry?
First line, publication of
Yeah.
entire schemas,
How that would work?
including future table editions.
Right.
I'm not sure what is that.
What do I mean by that? So a schema, this is maybe confusing. The relational systems use the word schema in two ways, okay? In one sense, a schema is the layout of a table. Okay, so you say, when I say create table X, call table test, X integer, Y integer, X and Y are the schema of the table, right? But relational systems also have the concept of schemas as collections of tables. They're called schemas. And we have a public schema by default in Postgres, and by default things will be created in that public schema. In fact, I have a blog entry. There's my URL, there's like 650 blogs, and one of them is called schema, cluster, because we use the word schema two ways and we use the word cluster two ways, and it's very confusing. But that's the terminology, unfortunately, we have. When I'm saying publish an entire schema, I'm basically saying if we have a public schema as being a collection of all the tables that we've defined in that database, we could just say, instead of having to mention each table for publication, we can just say, let's just publish the entire public schema to another server. And if somebody adds something to the public schema later, that new table will automatically get picked up as published to the other system. It is not a great, yeah, the terminology is not good. Also, there's a way for subscribers to skip specific transactions. So if there's a big data load or something you don't want to send over, you can actually specify, I believe it's a transaction ID, and it won't send it. There's some purpose for that. I'm not quite sure. Support for prepared transactions. Prepared transactions meaning you have like prepare and commit. If you've ever seen that system, that wasn't replicated before, it now is. Suppress replication of empty transactions. I didn't realize, I thought this was like stupid. I thought it was just fixing like somebody who does begin and commit, but no. It turns out we were replicating transactions that, like if you had a transaction and you didn't mention any of the tables that were replicated, we still sent something to the other end. And we're like, why are we doing this? So that's gone. And another one, if there's a replication error, you could potentially get subscribers to get into some kind of error loop because they're continuing to try and apply that. So now you can error out of that particular problem, right? So you can see this is kind of an infrastructure play. You're basically building out your army kind of, toward a goal. I'm not quite sure. I don't do a lot with logic replication, but I know that, as I said with foreign data wrappers, when we started out, it was real easy, but as it grew out, it became more and more capable. In fact, the gentleman yesterday said, I tried foreign data wrappers in 9.6 and they were too slow and I stopped using it, right? Now, if he tries them, I'm sure he'll find that it's much better. Same thing with replication, logic replication. You may have tried it for some sophisticated case, didn't work. Now it will. So it's that kind of thing. And then that builds the infrastructure. Then 2-3 years down the road, you start to doing something like bidirectional replication, right? Which we didn't have, but now because we're building the underlying part of it, you then have, that's an option that you didn't have without all this here. There's much smarter people than me that understand where we're going. I'm just the guy who has to figure out what it is we've added in the release notes. But it is amazing how when we need something, it's kind of already been there for us. Somebody's already done it. I'm working on sharding. I've been talking about that for a bunch of years. And it's a lot of incremental improvements that people have been doing over the years in partitioning, in foreign data wrappers, and in parallelism together that have gotten us where we are. And I think that's going to take us it's going to take us into a much larger sites, lots larger data options than we have now. But it wasn't just one thing. It was a lot of these little things that smart people did. So, questions? Great. Okay. Compression. This is a acronym like smorgasbord here. It took me a long time to get my head around exactly what was going on here. As you can imagine, compression, particularly of backups, was not something that we focused as much on as we have in this release. So we had some very rudimentary compression of pgdump. So when pgdump would write its results, you could compress that. But as you can see, a boatload of things have come in this release for that. The first one is LZ4 compression. We had gzip compression for base backup, which is what we use for like continuous archiving, a base backup of the directory. But now we can use LZ4, which is far superior in a lot of ways to gzip for this particular case. So the first one is talking about the compression of the protocol over the wire. Okay. The second one is talking about the compression of the files we store on disk. Not the wire protocol, but the disk storage, right? And there we've added the ability to do LZ4 and something called Z standard, or ZSTD if you've seen that before. And Z standard is actually in many ways better than LZ4. And we've had some discussion over why anyone would want LZ4 sometimes if we have Z standard. I'm not going to go there. We could do gzip before, but now we can do LZ4 and Z standard for the files, the base backup files we store on disk. We can also, in base backup, which is the continuous archiving tool, we can effectively control whether the compression happens on the database server or at the client. So there's like a new protocol. You define client dash or server dash. So you can do the compression on the server and then send it on the wire, or you can wait for it to come to the client and then compress it there, and depending on where you want to use the CPU, right? PG receive log, it's another tool we have. We already had gzip there, but now we have LZ4. And completely unrelated, full page writes, which is something that allows Postgres to be reliable. We already had LZ there, which is a very old compression protocol. Can somebody remind me what LZ stands for? Thank you. I knew it was one of those things. So now we have LZ4, which is superior to LZ, and Z standard for compression of those writes. So this is kind of a lot of acronyms and but it just took a while for me to get it around my head exactly what we did. It's kind of interesting, I thought. When I started to actually work on this talk, I had to go back to the release notes and make sure I had those right, and then I wasn't sure those were right, so I had to ask the community members, and then they had to tell me, no, this is, and then that's how it kind of worked forward. I fixed the release notes, and then I got it in my slides, and I'm like, all right, this is right. I'm not sure I'm explaining it, but obviously I'm excited to see we've really gotten serious about this, because up to before we just like kind of passed what we had. Granular permissions, I don't know what that B is there. I'm going to have to fix that. Excuse me about that. Granular permissions, they basically allow things like a view to be run by the permissions of the view user. Because up until now, if you create a view, anyone who access the view would be doing it as the owner of the view, which is good. It's like an escalation. You give people permission by creating a view, and even if they don't have permission on the table, if they have permission on the view, they can view the data. But some people wanted the ability not to have that happen. No problem, we allowed that. You can grant control to change server-side variables. That's kind of interesting. And we've added a new predefined role for checkpoint permission. I know, Stephen, in the previous talk, we talked about the idea of not using super user for everything, but giving people individual permissions, right? So instead of having users come into super user to do everything, you can say, I'm going to create an ordinary user who has checkpoint permission, or an ordinary user who has the ability to write to the file system, or an ordinary user that has a permission to view all tables, to do backups, right? And you then are segregating ordinary users with these special permissions, and you're not having to give the overall permission to the person who's logging. It's really nice. Okay, another huge grab bag for me is memory. Any questions? We're good? Okay. Another huge grab bag for me is memory. We've gotten pretty serious about this. I thought this was something we really couldn't improve much on. I thought it was just kind of, it is what it is. We've done the best we can. But no, there's a bunch of things that we can do. First, we now, our sorting algorithm goes back to Knuth, right? The guy, who wrote all those computer science books. But the sort of best state of art has actually improved. Things are continuing to improve. So, for example, I didn't think sorts could really be improved, but it turned out that sometimes when we were spilling sorts to disk, when they were too big for work mem, we were doing it in a stupid way, just a way that was inefficient. So we improved that. We improved the performance and reduced memory of sorts that didn't spill the disk. So the ones that spill the disk are better, and the ones that don't spill the disk are actually better. Again, I didn't think we could do a lot. I thought this area was kind of just settled. You know, you kind of have done the best you can. But it turns out that people continue to find things that actually improve it. And some of the numbers I saw were 20%. I was like, wow, that's, you know, I'll take that any day. Another thing, this third item is actually one of the biggest in my mind. Very hard to understand the value. But since I've been with Postgres since, I guess, 96, I guess about 2002, 2003, we created something called server statistics, right? It actually has a new name now. What is it, Stephen? What's the new name? Cumulative, the server statistics are called cumulative statistics, or, yeah, there's a new term. There's a new term in the docs. I guess that's why I know, because it's the docs the issue. But we've always had this server statistics concept where we allow, I'm not sure how many of you were in the talk yesterday about, there was a question yesterday about how would you know when there's an index and you should get rid of it? Does anyone remember that question? Okay. And the answer was you go to pgstat user tables or pgstat user indexes, and you can see how often the index has been accessed. Well, those statistics have been around for Postgres for almost 20 years, 18 years, whatever. And the bizarre thing is that the infrastructure that we used to do that up until this release was effectively to have a statistics daemon that ran. If you've ever looked at your processes, you'll see a statistics daemon. And we used UDP Ethernet packets, if you're familiar with UDP, aside from TCP, UDP, lossy, possible. We would send UDP packets to this collector. This collector would accumulate the statistics in its helper, and then it would write a file to the file system. And if somebody asked for pgstat all indexes or one of these, the back ends would read the file in the file system and then return you the result. Now, I've never really talked about that before because I didn't think we could make it better. But that's a really weird architecture, right? I mean, it's doing a whole bunch of things that just seem wrong. It's using UDP packets, which are lossy, and creating like packets on the network to communicate like every insert and every delete, right? And then this thing is writing it to the file system so other people can read the file system of what it's just written. Just really not a great architecture. So thankfully, Andres Food, who works for Microsoft, he got a bee in his bonnet or whatever, and he just said, we're going to fix it. And I remember the commits that came through for this thing were like, I don't know where this is going. Like, I think I know where it's going, but it's heady stuff. He's moving. Yeah, I mean, you can imagine this whole thing is being re-architected. And I'm seeing these patches that are humongous coming in. And I'm like, more power to him. Like, go, please fix this. And he did it. He started, I think, in October and finished in like February. So it was this long slog of just these massive commits. He's like, I'm going to rewrite this thing and make it memory based instead of network/file system based. But he had to restructure a whole bunch of stuff. God bless him, he did it. And now we don't have that wacky thing anymore. We basically have a runtime server statistics, which is in shared memory, which is where it should have been all along. There's no more UDP packets, and there's no more writing to the file system. So the data is more accurate. There's less network I/O. There's less file system I/O. Everything is much better. It's very hard to get excited for ordinary users to get excited about this, but as an architect person, yeah, I'm like, you know, it's sort of like you got a door and it's been like creaky and hard to open for like 10 years, and all of a sudden like a carpenter comes and actually fixes it, and like the next day you're like, oh my goodness, this door opens like normal. It's been 10 years. I wish I would have done this before, right? So anyway, that's how I feel about that one. Any questions about that rant? Okay. This is really interesting and kind of, I don't think it's controversial, but basically Postgres has various ways of doing in-memory operations like sorting and hashing and nested loop and so forth. What we found over time is that hashing is quite a bit more sensitive to memory and quite a bit better, let's say, than sorting. So if you spill to disk on a sort, you kind of can recover. It's not a huge problem because all the data is ordered, so you can do one group and then throw it away and then pull the next group out that you sorted and do it, whatever. You can't do that for hashing because hashing requires you to look at all the buckets at once. So what we did in this release is we actually allow hashing by default to use twice as much memory, twice as much work mem as other operations. So we've kind of tilted, we've sort of put our hand on the scale for hashing and said we're willing to do twice as much, allocate twice as much memory to a hash because hashes are in many ways faster and more sensitive to being spilled to disk than a sort would be. And we're going to see how that plays out, but I think initial results are that it's good. We added a multiplier for hash in 14, and this release we're actually using it and saying, okay, now we're going to actually be more aggressive in giving hashes more memory. Difficult situation, you're having to judge which one's a better solution, but I think it's going to turn out well. I'm optimistic. And we also have new server variables. Again, to make memory more visible, you can now see how much memory is being used, by how much shared memory is being used, and how much huge pages are being used, which was sort of an opaque thing before. I think we had, in the docs, we had some like command you could run from the command line. Now these are SQL level. You can just query it and see right away, this is what I'm using. And that's going to be useful if you're sizing shared memory for a system, or if you're trying to allocate huge pages. In fact, you can oddly, before the server starts, you can actually start Postgres and ask for how much huge pages it would want without starting it. And then you can go allocate those huge pages and then go in. So that was a tricky thing. We allowed a server variable to be queried before the server started because we know the server would crash because there isn't enough huge pages, right? So you can kind of say, here's what you're going to need to pass. And then you can do that and then trying it again. So there's some usability stuff here. The seventh one, this is kind of interesting to me. And this is a fun one, so yeah, I always end with a fun one. It's not going to set the world on fire, but I think it's a great example of where we're focusing on usability. So as you may know, when we created the copy command, we had a header clause. You specify the header clause kind of in parentheses like that, right? And up until now, the only copy format that supported the header clause was CSV, or comma separated value, okay? Because CSV, by definition, has this concept of a header, right? So we kind of went along with that. But what we didn't have is that for any of the other formats, like the text format, which we use very commonly. We just didn't have it. So here's an example of it being added. We basically create our table. Again, fantastic column names. Then we insert our two values, term paper and crossword puzzle. And you can see if I just do a copied std out, I get just my normal output. But now in non-CSV mode, in text mode, I can specify header, and I actually get the X and the Y to come out, right? Which wasn't true before. Now that might be just interesting, but it gets a little more interesting. For example, what I do now, if I copy my file to a temp file, and then I delete everything, and I try and load it in, I actually get an error. And the reason I get an error is because the X and the Y will not translate to integers, right? It's like you can't do that because X is an integer and Y is an integer. So if you dumped it out with header, you have to load it in with header. That's exactly what I've done here, right? But what gets more interesting is this one. If you effectively, if I rename one of the columns, so the column names don't match anymore. Now instead of being XY, it's XZ. And I try and copy it in, well, it actually works. And the reason it works is because I've just said header, but if I say header match, it will actually try and take these X and Y's and match them to column names. And if they don't match, I'll get an error. So the real value to me is it makes the whole copy operation less error prone. If you're loading it into the wrong table, if you're loading it, you somehow modified the table and you forgot, but from when you dumped it, right, you don't get this kind of surprise. So is it a huge feature? No. Is it something that I think is really cool and will make copy more useful and less likely to fail, less likely to surprise you? I think we'll succeed in that. Yes, sir.
Will loading with header match account for different ordering of columns as well as to match?
Okay, the question is, will loading of header match handle a case where the columns move around? And the answer is, I don't know. If somebody could test that, that would be great. And I had somebody. Yeah, I think that was part of the point, but it feels like it would be cool if it did. Yeah, but I can't say that for sure. But we have 5 minutes, and I'm sure some people have questions. So while the questions are going on, somebody will happily give me that answer. I can tell you as a speaker, not being comfortable not knowing the answer is like half of the battle. Like, I don't know. Somebody's going to find it for me, though. And usually if I have Magnus Hagender here, I make him do the legwork, but he's not here right now. So, okay, that is the end of my talk. I